Hey everyone, hope you're doing well. So today we're going to be having a quick look into Elasticsearch. If you enjoy this kind of content, please consider subscribing, and let's get right into it. So Elasticsearch is an open source search engine. So it's a tool with a data store that exposes a REST API, and it basically allows you to upload data or documents using the API to that store, and then it will index the data, and then of course using the API you can then query, aggregate, sort, filter, and basically search that data in a really kind of quick way. So in today's tutorial, what we're going to do is we're going to spin up an instance of Elasticsearch locally. It's very easy, very quick to do. And then we're going to upload some data and basically go through a few basic queries just to understand kind of how it works and how to get started with Elasticsearch. So let's get right into the code. So I have a brand new project here, and essentially what we have is a Docker Compose file, and this is how I'm going to be running Elasticsearch. So it's just an executable, and there's a few different ways to run it. I've gone for Docker here because I think it's quite nice and simple. So this basically just spins up an instance of Elasticsearch. It's just a single node. That's all I need for local environment. But of course, you can spin up kind of clusters or multi-node instances. I'm adding a volume here so I don't lose the data, and then I'm just exposing the ports that we're going to use. And I'm also adding an instance of Kibana here towards the end. I'm going to show you a nice kind of tip to play around with the queries using Kibana's DevTools. So next up, there's a file called Elasticsearch, and here we just have a bunch of HTTP calls, and we're just going to be using them to basically upload and query the API. So note here that I've got the curl commands above each of these commands, just in case you want to follow along with the command line. And finally, I've just got this accounts.json file, which I've taken from the Elasticsearch website, and this is just going to be used to bulk upload some data later on in the tutorial. So to get started, just go to the root of this project and just hit Docker Compose up, and that's going to spin up an instance of Elasticsearch and Kibana. So I'm just running it through my IDE, so I can see both of these containers running fine here. And the first command that we're going to learn about is basically the health check. So we need to make sure that our services are running fine. So everything's going to be prefixed by localhost 9200. That's where the API is exposed. And in this case, the very first API we're using, or resource we're using, is this _cat API. And this basically stands for compact aligned text, which is basically a nice format for you to see data from the API. This is meant to be used by humans, by developers, just to basically confirm data or have a look at health endpoints, etc. So we're using this health endpoint. We're passing in a flag just to tell it to show us the headers. And if I run play here, we can see that we have one instance here and the status screen. So it basically means everything's running, everything's fine. So let's go on to adding some data. So we're going to cover two ways of adding data. First, we'll just add like a single document, and later on we'll cover kind of a bulk upload. So to start off with a single document, super simple. In this case, we're using a put request, and this customer here is actually basically the name of the index. It's a dynamic kind of path variable, so this can be whatever we want. It's the type. And in this case, with this command, it's going to create the index for you if it doesn't exist. And if it does exist, it's just going to add this document to that index. So then we're just using this _doc path variable. And in this case, we're passing in the ID explicitly. So if we leave out the ID, it's going to generate that for us. In this case, I'm just popping it in so we can get it easily as well. And adding this flag to pretty much all requests just means format the data that we get back as part of the response. And then we just have application JSON header, and we have the body here, which is, this body can be whatever we want. So if I hit this request, that's going to go in some data back, basically saying that's successful, 200, everything's fine. And now if I want to see that data, we can move on to this second request, which is a simple get request. Again, we're going for the customer index, and we go for almost, I think it's exactly the same path. We're looking for this ID, so we can get that document by ID. And if I hit run here, we can see that there's some kind of metadata going on here, and then we have the source. So this _source is usually where the actual document is kept. So we can see here, name, John Doe, perfect. Now, of course, Elasticsearch is a search engine, so for the most part, you're not going to be getting by ID, and this is where basically queries come in, search queries, and we'll go into them a bit more later on, but here's kind of the most basic one here, which is essentially, let me just move this up a bit. Essentially, we're going to the customer index again, and this time instead of referencing a document, we're just doing the _search. And this is a get request, _search, and then the body here is going to contain the actual query that we want to use to fetch the data. In this case, I'm just doing the most basic query, which is, hey, just match everything, bring me back everything in this index. So if I run this, again, it's going to come back with a bit more metadata, the time it took in milliseconds, the number of, they're called hits, so the number of hits, in this case there are 1 document, and then the list of hits, and this is basically, again, we're going to see the source, name John Doe, and one quite important field here we're going to see is the score. The score is basically a weighting of how much this document matches your search term. In our case, our query just matched everything, so the score is just a perfect 1. Cool, so let's have a quick look into bulk loading objects or bulk loading data, and then we'll start to do a bit more in terms of the queries. So if I scroll down, the next query I have here is a bulk insert query. Again, we're using now a different index, and we're using this underscore bulk API here. And the body here, we're actually just referencing the accounts JSON file over here. Now, one thing to know with the accounts JSON file, if you take a look, it's not quite JSON. It's actually kind of a different variation of JSON called, I think it's New Line Delimiter, or ND-JSON, which is a format that's optimized for data streaming, which all it really means is every line, there's going to be a JSON object. So that's it. So you can see here, every single line, there is a JSON object. And the way Elasticsearch use this is the first line is, I think it's kind of metadata. So you can see we've got an indexed with, we're given each one an explicit ID here. And then the second line, or basically every even numbered line, is going to be the actual content, the actual document that you want to add. So basically these first 2 lines are basically saying add a document with ID 1, and here is the source, or here's the data for that document. So we're going to go back to the HTTP file here, and we're just going to run that request. And there we go. And so that one took a bit longer, and you can see that this one actually returned all the documents that it inserted here, which is absolutely fine. So one way again of checking the index, checking that everything went fine, is this get request. We're going to go to underscore cat, and it has another path called indices. And if I do a get there, we can see basically all the indexes. There's the bank index that we've just added. There's the customer one that we added earlier on. And in this case, the accounts JSON, there were 1,000 documents. So you can see we've added 1,000 documents. Cool. So let's have a look at some basic queries. So the first one we have here is we're again targeting the bank. And in this case, we're just matching all. So we're just keeping the query the same, but we want to sort by, in this case, let's say account number. Let me just take this size out here. So we're just sorting by account number, and we're just saying ascending. So this account number is one of the fields within the JSON file. So if I run this guy here, so that's going to work fine. I'm just going to scroll up to the top. Again, you're going to see this familiar pattern with hits, and then hits.hits will give you basically the list of the documents. And we can see that account number starts at 0, 1, 2, etc. And you'll notice that by default, it only goes up to 9. And that's because by default, Elasticsearch will have basically pagination implemented into its APIs. So it's only going to return the first 10 results. And you can manipulate that using basically the size parameter right here. So you can add a size attribute, and you can give it a number. So in this case, I'm going to give it 100. I think there is a max number. I can't quite remember what it is. I think it might be 1,000, but let's give 100 a go. And it's basically saying go for 100 documents. So you can see it's gone up to account number 99. And the opposite side of that is we can start at different indexes as well. So I can say from 99, which should basically start at 99 and then go down 100 from there. So I think that should take me to just under 200. And if I go up to the very top, it should have started at 99. There we go. So next up, let's have a quick look at basically matching a field in terms of text. So in this case, we have a query, and what we're doing is we're matching the field address, and we're passing in two strings, or a string with a space separation. Now, there's different queries, and they're going to behave slightly differently. So in this case, when we say match, we're basically saying match each word individually, right? So if I run this query here, the match is going to return, 19 results, and each of these results will have mill or lane. So one of the two phrases, right? So we have a look at the very first result here, and we can see that this is a score of 9.5. So this is quite a high score, and that's because it has mill and lane. So it's got both of them. If we go to the second one, that's got a much lower score, 5.4, roughly half, and that's because it only has one of the words just mill. If we go down, this one's also got mill, and we might find some that just have lane. There we go. So that's that search. If we wanted to, for example, search anything that had mill lane in it, we can change this query. So this query is called match. We can do match, I think it's phrase, and we can run that exact same query, and in this case, we can see that it's actually only brought back one document, which is the mill lane one that we saw earlier on. This final query is basically looking for any of the account holders in our bank that are 40 years old and that don't live in Idaho. So that's the state abbreviation ID. So we can see here we have a query. We have this kind of bool flag, which basically combines multiple queries within it. So we can say bool combine these, and then we have a further query nested inside. So this one is a must query, and within that query we have a match query, and the match query then matches this rule. So it's matching age is 40, and then again we also have must not match state ID. It accumulates them two queries and performs the search. So if we run this one here, open this up again, we're going to see a few search results. We can see they're all going to be 40, and the state, none of them is going to be ID. So hopefully you can kind of start to see there's lots of different queries that Elasticsearch will provide. They've got quite good documentation in terms of the APIs, and basically you're going to go about mixing and matching the different queries to get the results that you want. Cool. So the final thing I want to show is how you can basically build up these queries using Kibana, which is quite a powerful thing to do. So Kibana is another part of the kind of Elastic Teams tools, and it's basically a visualization tool. It gives you dashboards, gives you metrics and everything, all based off of your Elasticsearch database or your Elasticsearch data store. So you can do all kinds of things. It's usually good for monitoring analytics, creating dashboards, etc. But one powerful thing that I want to look at here is actually if you go to the menu at the top left and you just jump down to DevTools, you can jump into this DevTools. You've basically got this console where you can start doing queries directly against all your data, and it's kind of got this autocomplete functionality that will basically help you do that. So this is always going to start with, for the most part, it's going to start with get, and if I do again control space, and you can basically see, there we go. That's my bank index. I've also got the customer one as well, all there in the autocomplete. So if I do bank/search. And then I can start building out my query. So I would type a query. Again, it's got the autocomplete there, and then I can just see all the different options right here for me. So I might do, in this case, match all, simple as that, and I hit Command Enter, and it's just going to run that query, and I can see it on the right hand side. So that's super nice, super simple, and then I can copy this query, create another one here, and I can start doing different queries here. So I might do match, phrase was it? And then it auto populates that. So let's do address, and we said mill lane. There we go, filtering and searching this one. I think it's also got this auto indent. Yeah, there we go. So this is very useful, especially for playing around with different queries. And one other thing you can do is you can take this query. For example, let me just take this query right here. I can head over to this tab right here, which is the search profiler, and basically paste that query in. And in terms of the index here, I think I can just type in the bank index. Here's my query. I can go down to profile, so scroll down a bit, and it will basically give you a summary of how long the query took. And then there's a bit more details in terms of breakdown of what's taken the longest. So if you wanted to really work on optimizing your queries, you might try different methods, etc. Yeah, I think that's everything I wanted to cover in Kibana, and I think I've covered everything I wanted to in Elasticsearch. Hopefully this gives you a good idea of how it works, what it's for, and enough to basically start playing around with it. So yeah, thank you very much for watching. Have a good day, and I'll see you in the next one.